Halo. 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 Check. Halo. 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 Check. Test. Halo.
હાલો. હાલો. હાલો મેચ છે. હાલો.
convener of the conference, Professor HOD, Computer Science and Engineering, to escort the dignitaries onto the dais. Please be seated. A very good morning and a warm welcome to one and all present here today. We have gathered here for the inaugural function of Second International Conference on Recent Innovations in Computer Science, ICRICS 2023. ICRICS 2023 provides a platform where brilliant individuals from around the world come together to share their revolutionary research in the field of computer science. To keep us updated with the technology changes that are happening at a very fast pace today and seamlessly integrate it into our life, computer science and engineering, Master of Computer Application, Information Science, AIML and AIDS departments have taken the initiative to host ICRICS 2023 in collaboration with ICT Academy. We are indeed honored to have the presence of distinguished academicians with us today.
Every occasion must begin with the blessings of God. Prayer is the best way to reach the heart of God. Prayer is not asking, it is putting oneself in the hands of God and listening to His voice in the depth of our hearts. I invite Professor Shweta Hebbal, Department of Mathematics, to lead us in prayer. I request everyone to kindly rise.
गजमुखने सिद्धिदायकने वंदिपे शरणो गजमुखने सिद्धिदायकने वंदिपे शरणो त्रिजगवंदितनाय देव देवने शरणो सुजननिगे विघ्नवनु परिहल्पे शरणो गजमुखने सिद्धिदायकने वंदिपे शरणो सनि 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 गरि सनि स निद 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 पम पदनि सरि ग म पदनि सरि गरि सनि दनि स सरि गरि सनि दनि सनि द प गरि सनि द प म गरि सरि ग म पद सिद्धिदायक निन्न होति मेरे वेणुनानु अभिषयनन महिमे बधरली पेड्वा ಶುದ್ಧಮತಿಯನ್ನು ಕೊಟ್ಟು ಉದ್ಧರಿಸಬೇಕೆನ್ನ ಶುದ್ಧಮತಿಯನ್ನು ಕೊಟ್ಟು ಉದ್ಧರಿಸಬೇಕೆನ್ನ ಮಧ್ವವಲ್ಲಭ ಸಿರಿ ಕೃಷ್ಣ ಗತಿ ಪ್ರಿಯ ಮಧ್ವವಲ್ಲಭ ಸಿರಿ ಕೃಷ್ಣ ಗತಿ ಪ್ರಿಯ ಗಜಮುಖನೆ ಸಿದ್ಧಿದಾಯಕನೆ ವಂದಿಪೆ ಶರಣು ಗಜಮುಖನೆ ಸಿದ್ಧಿದಾಯಕನೆ ವಂದಿಪೆ ಶರಣು ವಂದಿಪೆ ಶರಣು ವಂದಿಪೆ ಶರಣು ವಂದಿಪೆ ಶರಣು
Thank you, Professor Shweta Hebbal, for invoking God's blessings.
Welcome is a universal gesture of goodwill and hospitality. A hearty welcoming always brings the warmth and smile and joy. Now I invite Dr. Shashidhar Giri, HOD, Master of Computer Applications, to welcome the august gathering.
Good morning, ladies and gentlemen. respected President of today's function and our beloved Principal Dr. Srinivasa Mayadi, Chief Guest of the function Mr. D. Vishnu Prasad, State Head Karnataka ICT Academy, Keynote Speakers Dr. Raghavendra U and Dr. Anjan Gulikar, Associate Professors MIT Manipal, Invited Speaker for tomorrow Mr. Sunil Utharaju Rampura, Head IT Operation, D. Montfort University, Kazakhstan, Professor Ravishankar Convener, all the HODs of Computer Science and Allied branches, other department HODs, my dear colleagues, research scholars from institution bar software industry, and dear students. It is a moment of great pleasure and honor for me to extend a hearty welcome to all of you today in this memorable event of Second International Conference on Recent Innovations in Computer Science, ICRICS-2023 of Computer Science and Allied branches of Srinivas Institute of Technology, Valachi, Mangalore. We are indeed privileged to have with us our beloved Principal, Dr. Srinivasa Mayadi, as the President of today's function. His hard work and dedication make Srinivas Institute of Technology what is today. On behalf of the organizing committee and on my personal behalf, we extend a warm welcome to you, sir. We welcome our President and Chancellor of Srinivas University, Shri Dr. C.A. Raghavendra Rao, and Vice President and Pro-Chancellor of Srinivas University, Dr. E. Srinivasa Rao, Director Srimati Vijay Lakshmi R. Rao, and Srimati Mishra S. Rao, Secretary Srinivas Group of Colleges in their absentia. We have with us Mr. D. Vishnu Prasad, State Head Karnataka ICT Academy as the Chief Guest of this function. On behalf of the organizing committee and on my personal behalf, we welcome you, sir. We have keynote speakers and guests of honor, Dr. Raghavendra U and Dr. Anjan Gulikar, Associate Professors, MIT Manipal. On behalf of organizing committee and the entire group of Srinivas Institute of Technology, we welcome you, sirs. We welcome the invited speaker for tomorrow, Mr. Sunil Utharaju Rampura, Head IT Operations, D. Montfort University, Kazakhstan. On behalf of the organizing committee, we welcome you, sir, in advance. We welcome all the principals of our sister institutions, HODs of various departments to this function. We welcome all the paper presenters, research scholars from various institutions to this international conference. We welcome our teaching and non-teaching and technical staff as well as students to this function. Finally, we welcome one and all for this August gathering. Thank you one and all.
Thank you, sir.
Floral welcome adds grace to oral welcome. It is time now to florally welcome all the dignitaries on the dais. I now request our Honorable Principal, Dr. Srinivas Mayadi, SIT Mangalore, to florally welcome Chief Guest of our today's function, that is Mr. Vishnu Prasad, State Head, Karnataka ICT Academy.
Now I request Professor Ravishankar K, HOD, CSC, to florally welcome President of today's function, Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, Mangalore.
I now request Professor Atma Ranjan, Department of ISC, to florally welcome Dr. Raghavendra U, Associate Professor, MIT Manipal.
Now I call upon Dr. Jose Alex, Department of AIDS, to florally welcome Dr. Anjan Gulikar, Associate Professor, MIT Manipal.
Thank you. To succeed, you need to find someone to rely on, someone to motivate, and someone to inspire you. I now request Professor Arvind Naik, Department of Computer Science and Engineering, to introduce the Chief Guest, Mr. Vishnu Prasad D, and the keynote speakers of today's program, Dr. Raghavendra U and Dr. Anjan Gulikar.
Good morning, one and all. Respected dignitaries, on and off the days, my dear colleagues and students. It's my proud privilege to introduce Chief Guest of this function, Dr. Vishnu Prasad, State Head, ICT Academy, Karnataka. He is a Master of Computer Application graduate with more than 14 years of experience in education and training industry. He started his career as a junior executive and elevated to the level of State Head. Dr. Vishnu Prasad served in various organizations in different capacities, which include business development, strategy formation, technology implementation, digital marketing, and corporate relations. Played a key role in expanding point of presence when he was associated with one of India's leading education company headquartered in Chennai. Dr. Vishnu Prasad associated with ICT Academy since 2010 and heads the Karnataka state. He has also been instrumental in signing MOU with major institutions and universities across South India. Sir, we are extremely grateful to have you amongst us. Thank you. On this occasion, I would like to introduce keynote speakers, Dr. Raghavendra Yu and Dr. Anjan Gudiga. Dr. Raghavendra Yu worked as a faculty in the Department of Instrumentation and Control Engineering, Manipal Institute of Technology at Manipal. He completed his BE and MTech from VTU Belgaum in the year 2006 and 2010 respectively. He received his PhD from Manipal University in the year 2014. He has published several research papers in referred international SCIIF Science Citations Index journals and international conference proceedings. He has a patent to his credit and received Invention Award from Intellectual Ventures, USA for his inventions on object detection and tracking systems in the year 2014. He has several international collaborations on developing early prediction algorithms for life-threatening diseases. His major academic interests are in biomedical signal processing, biomedical imaging, data mining, visualization, and biophysics for better healthcare design, delivery, and therapy. Dr. Anjan Gudiga received the PhD degree from the Manipal Academy of Higher Education, India. He is currently a faculty in the Department of Instrumentation and Control Engineering, Manipal Institute of Technology, Manipal. He has published several research articles in international conferences and journals. His research interests include image processing, medical image analysis, and pattern recognition. With eager anticipation, let us open our hearts and minds to the wisdom and insights that our keynote speakers are about to share. Thank you, sirs. Thank you.
Thank you, sir.
Shubham Kurutvam Kalyanam Arogyam Dhanasampada Shatru Buddhi Vinashaya Deepa Jyotir Namostute. I now request the dignitaries on the desk to light the lamp and inaugurate the function. I request everyone to kindly rise. I also request any two participants to assist in lighting the lamp.
Now I request the convener of the program, Professor Ravi HOD, Computer Science and Engineering, to give an overview of ICRICS ICRICS-2023.
Good morning, everyone. Respected dignitaries on the days and of the days, my dear colleagues, students. I'm here to present a brief report on the second international conference on recent innovations in computer science, that is ICRICS-2023, organized by the departments of CS and allied branches, SIT Mangalore. The aim of ICRICS-2023 is to create a platform to foster thinking and innovation in technology and maintain the competence of the profession. The conference intends to have deliberations on advanced topics of computer science and its application in different domains. The theoretical topics, together with real-time research from various streams, are going to be presented and discussed in the conference for 2 days. ICRICS-2023 is a multi-track conference being held today, 22nd, and tomorrow, 23rd June 2023. The broader areas of computer science are divided into 4 tracks: artificial intelligence and machine learning, computer vision and image processing, enabling technologies, and cloud computing. Total of 112 papers will be presented in this conference. 78 papers will be presented in the online mode, and 34 papers will be presented in offline mode. We have adopted stringent plagiarism policy of similarity index below 15%. Also, we carried out 2 blindfolded review for the process of reviewing. We have publication tie-up with UGC approved high impact factor ICT ACT journals and Google Scholar indexed IRJIET International Research Journal of Innovations in Engineering and Technology. Depending on the quality of the research papers, we are going to classify them into 3 qualities: A, B, and C. Papers of quality A, best 20 papers will be published in ICT ACT journals. Papers of quality B, remaining 50 papers will be published with the IRJIET, which is Google Scholar Index, and remaining papers of quality C will be published in the Google Scholar Index Institutional Journal, Srinivas Publications. On this occasion, I request all the authors and audience to wholeheartedly involve and share their ideas. Best paper award will be given to a total of 8 papers, that is 2 from each track, in the validating program tomorrow. On this occasion, I thank our management for their continuous support and encouragement. Also, if I don't thank ICT team, I would fail in my duty. I thank Vishnu Prasad and also Vignesh Shetty from ICT for providing this opportunity to us. Also, I thank keynote speakers Dr. Raghavendra Yu and Dr. Anjan Budigar from MIT Manipal. Also, I thank Sunil from Kazakhstan, who is going to deliver keynote address tomorrow. I am grateful to Dr. Srinivas Maya, principal of the institution, for his guidance throughout. And also not to forget the untiring efforts of all the organizing committee members. I hope this conference is going to be fruitful to all of us. Thank you, one and all.
Thank you, sir.
Motivation is not permanent, but it can be received and nurtured on a regular basis. It is the mere words of motivation that ignite the sparks of creativity in our minds. Now I request the chief guest of today's function, Mr. Vishnu Prasad D, to address the gathering.
Good morning, everyone. Respected dignitaries in the dais, respected President Dr. C. A. Raghavendra Rao sir on his absence here, respected Principal Sir Srinivas Maya sir, who I consider to be my mentor, respected Ravishekar sir, HOD of MCA, respected Associate Professors from Manipal, Mr. Dr. Raghavendra and Dr. Anjan Budigar, respected HODs of various departments, faculty members of various departments, research scholars from various other institutions, and research scholars from various other universities, students of Srinivas Institute of Technology. A very warm good morning to everyone. Always a program in Srinivas Institute of Technology is very heartwarming to me, because as I was speaking with the principal sir, I just remember 5-6 years back, 2017, when ICT Academy entered Karnataka after Niti Aayog's report, the first college to sign in entire Karnataka was Srinivas University and Srinivas Institute of Technology. That is the visionary of our beloved principal, Dr. Srinivas Maya sir, who has taken up this initiative. Till that time now, always I could see that the institution is always fast forward in thinking, because in the year 2017 when we discussed, they didn't even, not only the institution signed up with the ICT Academy, they have also set up a center of excellence on data analytics in association with one of our corporate partner, Dell EMC. Also, Srinivas Institute of Technology is the first college to set up that center of excellence also. So, today's international conference on recent innovations in computer science. ICT Academy is privileged and also very happy to collaborate with such international conferences, because that is where innovations come into play. That is what ICT Academy is all about. And also, for few of the professors who are here who have not heard about ICT Academy, I want to just give a snapshot about ICT Academy. ICT Academy is an initiative of Government of India. It was started in the year 2017. Our chairman is none other than Mr. Josh Holger, who is the chairman of Foxconn. I know you, all of you like Apple products. The manufacturer of Apple products is Foxconn. The managing director India of Foxconn, Mr. Josh Holger, is our chairman. We have in our board director Mr. Lakshmi Narayanan, who is the emeritus vice chairman of Cognizant. We have from TCS Mr. Chris Ganeshan, who is the ex-vice president and head of recruiting in TCS. And we have Mr. Balakrishnan, who is the ex-CFO of Infosys and chairman of Microgram. And we have 30 plus CEOs and CTOs, CXOs of various organizations who are contributing in our board of studies. We do a simple job of getting the industry content and giving it to the institutions. So we work with around 2,000 institutions across India. We work with the Government of India and we have successfully implemented 40 plus skill development projects in various states. And even this year we have signed up with AICTE, All India Council for Technical Education, wherein through AICTE we are training some 5,000 students in Ladakh, J&K region, on various skill development initiatives. Last year we have trained around 18,000 students in Northeast also. That was also a project of AICTE where we were implementation partner. So this is a small snapshot about ICT Academy. So I believe Srinivas group of institutions is immensely benefited with all our programs of faculty development and student enhancement programs. So how ICT Academy can contribute or contributing to recent innovation in computer science is what I wanted to go share it with you. And also I wanted everyone to utilize ICT Academy. It's not only for member institutions, it's for everyone who want to take up the advantage of ICT Academy. We have our faculty development initiatives wherein we collaborate with our corporates like Microsoft, Google, all these corporate players, and we are providing the training to the student, to the faculty members. We do not touch anything on your academics because we know that you are the best in that and we do not want to replicate that. So we give only the content that is needed for the industry. Okay, so which is not covered in your syllabus we are providing. So all the research scholars and students, research scholars and professors can utilize this, attend our faculty development programs where we are in association with Google, we are doing Kotlin programming, in association with Celonis, we are providing data analytics for Power BI and data analytics and Azure AI, we are collaborating with Microsoft kind of organizations. So our faculty development programs are open to all institutions of Karnataka. Even coming Monday, we are doing a program on R programming, which is supported by Dell, which is for all BTU institutions of Karnataka. So likewise, to get into innovation, first thing is skill. So to get that skills, we are providing the faculty development program so that you can learn the technology and you can fast forward. Second thing is you need corporate support. How to get into the innovation, what is that going into the industry. So for colleges of ICT Academy, we are collaborating with companies like Oracle, like Celonis, because already Srinivas Institute of Technology is already a member of Oracle, already a Celonis Academic Alliance partner. We have provided UiPath Academic Alliance also, kind of corporate partnerships, so that the corporates and the industry will be backing you to learn the technology, to enhance it. And even we are in association with Autodesk, we conduct a design competition every year for mechanical engineering and aeronautical engineering students, wherein the best of the products are being designed. Last year, one of the winners was from Karnataka only. Kailas Gupta Institute of Technology. Student has designed a product that was a winning project in Autodesk Design Academy, and even many faculties and students are attending those workshops. So those kind of corporate participation is provided by ICT Academy to enhance that. So that is one another thing, which is corporate participation. Third is research collaboration. As Sir said, we have 4 UGC CAD journals, which is on technology, which is on communication technology, soft computing, image and video processing, and microelectronics. Then I can proudly say that only our journals are there in UGC CAD for past 3 to 4 years because of our quality. We have eminent professors from various universities, Professor Ashok Jujunwala from IIT, we have from Stanford, from whatever big league universities that you are telling. Those professors are contributing to this journal on a not-for-profit basis. So even for publishing the paper in this journal, we are not charging anything from the authors, which stands for the quality. But only thing is, we are doing a double-blind review process to scrutinize the papers. Only the quality is important for us. The paper is of great quality. It will be published in our journals. We need not spend even a single penny for it. That way we are contributing to your research papers, and it is well indexed with various libraries. You can please visit ictastjournals.in for more information. Number 4, what is there for my student friends who are there, who are attending these conferences, to how to innovate or how to take your ideas to fast forward. Similar to what I said for faculties, first you need to learn the technology. To learn the technologies for my student friends, we are conducting many programs like Learnathon and Skillathon, wherein we collaborate with some 10 or 12 corporate partners like Cisco, Microsoft, Google, and we are providing free certification courses for you. Wherein it's all self-paced programs, you can enroll on that, and you can learn the technology, and you can either, that is true choice for the students. Either you can be looking out for a job, or you wanted to be an entrepreneur or an inventor. For both the things, the technology ICT Academy is supporting. One more thing is how to test the knowledge of mind. We have conducted many hackathons. Even last year we conducted a hackathon with UiPath, where we had around 1 lakh software bots which are built by students. I can tell one of the college in Bangalore, one student has built a bot to send students' mark to the parents. What you do normally, faculties used to sit and used to send messages individually to the group or anything. But a student, after using that technology, UiPath RPA technology, has created a software bot which sends messages of marks directly to the parents. Only the faculty has to put one Excel file inside a folder. That's it. The bot will work on its own. Internet should be connected. It will connect to a messenger server, and it sends. That is what innovation is all about. And also, I wanted to remind you one thing. When you are innovating, you do not think, or always students think innovation is soft big words like AI, ML. All fantasy words is what innovation is all about. Not that, friends. A simple problem which you can solve in your home or in your college is an innovation, which is real implementing one. This is a real innovation, because how many classes would be in a college? How many marks should be sent to every student? But with a simple software program, the marks are being sent by the individual software board. That is an innovation. So don't think on a higher perspective. Yes, you have to think on higher perspective, but start with the basics. Identify a problem, solve it, you are an innovator. It need not be a big problem or a small problem. Even I tell to my, whenever I go to the college, I tell to my student friends that for your project ideas, you need not go to anywhere. Look around you. there are thousands of problems around you. If you can build a solution for it, that is your project. And I hope industry is validating such kind of projects rather than skills. Now, most of the industries are not looking at your resume. You know that, right? Only a software scans through your resume and you are taken into next levels. Even 2 days back, I met a HR from TCS. They said that, sir, our now the process for recruitment is flawed. Across India, everyone wants to take up the national eligibility test, which is conducted by TCS. We are going through this, and how they are doing reality. I asked them, sir, how you are doing that, but how you filter the best of the students? Sir, we only find out whether they have actively involved in the technology and have developed a simple solution in order to solve some problems. If that is done, that is the students that we wanted. Is what the reply from them. So, innovation is done. So you might be in your first year, second year, third year, whatever it is. From now, start off building simple solutions. Even if it can be a grocery store nearby your home. You wanted to solve that problem of giving a bill, build a software that is enough. It can be a small, even if your college needs an admission software. If you wanted to do a data analytics, you may not take up big data. Data of last 5-year admissions of your college is there. You can predict what are the courses that your students are, colleges who are going to get in next 2 or 3 years, so that your college will prepare the infrastructure accordingly. Kind of lot of data is around there, so lot of innovation and projects can evolve out of it. So that is how ICT Academy is helping for the students. Not only that, we are building hackathons and we are bringing in competitions for the students. Even we have our youth talk competition. I hope many of the students have participated in the previous years also, where speaking and presenting, that is also a skill. Because once you are innovated, once you are coming out with innovation, you need to present it in a beautiful way. Yes or not? If you are unable to present it in a beautiful way, you cannot go, because you have to take your innovation to global stages. So speaking competition we are building, we are bringing a presentation competition. We come out with Student Innovator Award competition every year. It is to find the best project that has been built by a student. We see only one thing, whether it is real-time implementable, whether it is implemented already. That is the 2 criteria we see. So those kind of competitions we are conducting for you, so you can do that. So, and also we can get you, I hope already you would have attended plenty of lectures. We have implemented many of the corporate programs here, like Honeywell. Many other corporates are ready to invest, because this is a time of opportunity for research scholars or for students. Whatever support, because earlier what you used to be, since I am interacting with the industry, I come to know. This year, for ICT Academy, we have signed up with already 2 partners called Honeywell and Atos. We are setting up a center of excellence in 16 colleges across Karnataka for building skills. This was not the case 10 years back. I want to tell you what is the industry scenario. Industry is ready to come forward. They are ready to come to your doorstep to provide technology support for your innovation things. Only thing is, your interest, effort and time is needed. Similarly, we are signing up with many other companies. Capgemini. For Bangalore, we are doing a dry run of only some 2 colleges, wherein they are training the students on 420 hours of modules, which is more than 2 semesters, to test out how this can be implemented on full stack development. So for girls students, for research scholars, there is umpty number of opportunities. And there is plenty of funds available also. Since we are working with government, we know that. We come to know from my Delhi AVP, I came to know that plenty of funds are not claimed by the institutions which are lying with major of the funding agencies in Delhi. If you could apply for it, you can get more funds. So likewise, this is a time for opportunity, and this is the right time for conducting this kind of conference on recent innovations in computer science. And we are privileged to collaborate with Srinivas Institute of Technology. We will continue to collaborate We look forward for active participation, actively participate, actively contribute journals, papers to our journals, not only now, any time of the year, since Srinivas Institute of Technology is associated member of ICT Academy, any time of the year you wanted to submit a paper, you are allowed to submit the paper at no cost. We will not charge you a single penny. That is the advantage that you are going to get. Okay? So please utilize, and even for the students, if you can build up a good research paper, you can do that. And also, we have other publications such as ICT Connect magazine also, wherein we are getting articles from industry, and industry authors are authoring. Even I request professors, we have eminent professors from our institution, if you want to contribute to articles, please share it to us. Your knowledge will be shared to around 2,000 colleges, government agencies, and also for the corporates. Because it is always a win-win situation. Corporate doesn't say learn from us. Corporate always says come together, we will together learn. That is the strategy for now and for the future also. So thank you for inviting me, sir. It's as I said, Srinivas Maya sir, I consider him as a mentor figure for me. So it's always a privilege to be along with him in the stage. Thank you for inviting me to this conference. I wish all the success for this conference and looking forward to get research papers from all your research scholars. Thank you.
Thank you, sir, for your words of wisdom and the support you have extended for our conference, ICRICS-2023, and for our student community.
The release of abstracts highlights the power of sharing knowledge. I request Professor Madhusudan, Department of AIML, who worked tirelessly to curate and compile the abstracts into cohesive and insightful book, to assist in releasing book of abstracts. Thank you, sir.
I now kindly request Dr. Raghavendra U, Associate Professor, MIT Manipal, to address the gathering and share a few words of wisdom.
Good morning to all of you. Dignitaries on the dais, and the participants who are attending online. First of all, I would like to thank management, principal sir, and entire family of SIT for inviting me to this conference, because it's in line with what we are working at MIT. And also, I don't want to take much of your time. We'll have a good discussion during my presentation. And I wish all the best to this conference, and have a fruitful discussion, and take away good solutions for your problems which you have in your mind. And we'll have a continuous collaboration in future if you are interested in our field of what is the trend or in line with your topic of today's conference. And wish you all the best. Thank you very much.
Thank you very much, sir, for your words. I now invite Dr. Anjan Gudigar, Associate Professor, MIT Manipal, to address the audience and share valuable insights and advice.
Good morning, everyone. I'm very glad to be a part of this conference, and I thank to the management team as well as the convener of this conference, and definitely we will discuss current research trends in AI techniques more in detail during the keynote address. And I thank, by looking at the gathering, I can feel that your principal, Maya sir, is very keen towards the research, and also the faculty members are eager to learn something new, right? So we'll have more discussion in the keynote address. Thank you all for inviting us, and we'll share our thoughts, and we'll discuss a lot of things, the current state of the arts, everything. And thank you so much. Wish you all the very best.
Thank you very much for your words.
One cannot achieve greatness without any moral support and guidance. It is an honor to have someone who brings out the best in us, being a backbone of all our activities and an endless stream of encouragement. I now request President of today's function, Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, to address the gathering.
Good morning. Mr. Vishnu Prasad, State Head, ICT Academy, Raghavendra Yu and Dr. Raghavendra Yu and Dr. Anjan Gudigur, Associate Professor, MIT, Dr. Shishir, Professor Ravishankar, my colleagues and dear students. As you already briefed about what about international conference, what is the main theme of the international conferences. So as all may be aware of that, recent innovations in computer science. There's a lot of innovations happening in the field of computer science, but limitations only left to our thinking. Maybe in future, alternate to human being is artificial intelligence. This is the big questions will be there. You can think that all people are working on that directions. Okay, the questions also comes, if artificial intelligence takes real work, okay, then what is the work left for the human beings? Maybe a robot, or even saying that many new innovations in the markets, all latest developments is happening. You may be reading in the articles or in the journals, etc. Where is going to lead? It's going to lead to the new era of generations going to be. Okay. We also, human beings also to be think higher than what the technology develops. Then only it is possible. So, what is this innovations? Each one have maybe different type of thinking. How you can able to implement with the latest technology, that's the innovations. Maybe the computer field or maybe another field, the people will think in the different directions. So, you can't able to take directly the products. You have to come to like this type of international conferences or national conferences. It should be opened up for the discussion. It should be discussed by a lot of people, and a lot of ideas, new ideas will come forward. Then it will get published in the journals, later on to be the patents, and then it can be released in the market, the products. So why is this type of conference is required? As now Professor already listed that 124 papers will be there. New 124 ideas going to be discussed in these conferences based upon the interested areas of the people. It is broadly classified into 4 areas. So you can also sit in there, you can learn what happening it and how you can able to carry forward, and you can contribute to that research work. That is the reasons that if you attend the conferences, you learn a lot of ideas, and you can develop the new products in the coming days. For inaugurating the program, we invited Mr. Vishnu Prasad. He is the person who is already briefed about that. When ICT Academy was formed and it came to Karnataka, he was traveling throughout the Karnataka. When he is approached our college, we want to encash that opportunities. We encash that opportunities. Later on, whatever the new initiatives comes from the ICT, he is always interacting with us and he giving the first preference to our college. The same thing when we ask for the publications of our papers, he is readily accepted to publish our papers in the UGC CAT journals. And he also spoke to now about the recent innovations, how ICT Academy helps for the students community to get involved in the innovations. Maybe last year, our students also participated one of the special program is a Tata Honeywell program only for women. Okay, more than 100 students and our teachers have participated in the program. Okay, like that new type of whatever the programs comes, we are encashing the ICT Academy for on the benefit of the students. So we approached him to publish our papers. He is readily agreed and he is traveled from Bangalore to here to inaugurate the program. We are thankful to Vishnu Prasad. And coming to the other part will be who will be the keynote speakers who can able to give open up about the conferences. We had a long discussions. It may be industry people or it's academic people. Okay. Getting the industry people and talking on the innovations. There are a lot of restrictions from the industry sides will always be there. They will not come like opening with the new topics and discussions because of the future patents or company rules, regulations, etc. So we felt that who are contributing in the research work on the recent developments on innovations in computer science, we felt that Dr. Raghavendra and Dr. Anjan Budigar will be the best people. We invited them to come here. They are readily accepted and came here for giving a keynote address to all of you. So I request all the participants actively participate these 2 days and think on that, what is the recent innovations happening and how you can develop further in future. So don't leave it here only and from tomorrow evening, what you carry forward on few areas, few topics you may be interested, future you develop on that, the latest things including the paper publications and maybe getting the patent in the coming years. So of course I would like to thank Professor Ravishankar and his team for organizing the second international conference on innovations in computer science. I wish all of you a good day. Thank you.
Thank you, sir, for your enlightening and inspiring message.
To express our deep appreciation for their valuable presence and contributions, I kindly request President of today's function, Dr. Srinivasa Mayadi, Principal, Srinivasa Institute of Technology, to present a memento to our esteemed Chief Guest, Mr. Vishnu Prasad D. Dr. Anjan Budigar as a token of our love
and of the dance. Thank you is a small word for expressing our gratitude. It is with immense pleasure and gratitude that I stand before you today to deliver the vote of thanks on this occasion. We extend our sincere gratitude to our respected Chief Guest, D. Vishnu Prasad, State Director, Karnataka ICT Academy, whose valuable insights, expertise, and inspiring address have enriched our understanding and motivated us to strive for the greater heights. Your presence has added a touch of distinction to this conference, and we are deeply grateful for your valuable contributions. Thank you, sir. We would like to express our sincere gratitude to our admired principal, Dr. Srinivasa Mayadi, for gracing us with his presence and unwavering support throughout this conference. Your visionary leadership, guidance, and commitment to promoting academic excellence have been inspiring to us all. We are truly honored to have your presence and encouragement, sir. Thank you, sir. Our sincere appreciation also goes to all the invited speakers, Dr. Raghavendra Yu and Dr. Anjan Budiga, Associate Professors, MIT Manipal, whose expertise, knowledge, and captivating presentations are the highlight of this conference. Your willingness to share your research insights and experience has broadened our horizons and inspired us all. Your contributions have truly made a significant impact, and we are grateful for your invaluable presence. Thank you, sirs. We would like to express our deepest gratitude to our convener, Professor Avishankar K, HOD, CSE, and Chair of the Conference, Dr. Shashidhar Pedi, HOD, MCA, for their constant guidance and support throughout this conference. Thank you, sirs. We would also like to express our deep appreciation to the heads of other departments who have graciously extended support and expertise. Thank you, sirs. To all the participants, we extend our heartfelt thanks for your active engagement, enthusiastic participation, and valuable contributions throughout this conference that you're going to make. Thank you. Lastly, we would like to express our profound gratitude to the organizing committee members and the dedicated staff, both teaching and non-teaching, who have worked tirelessly to make this conference a resounding success. Thank you. Let us carry the knowledge gained, connections made, and inspiration received here into our future endeavors, making a positive impact in our respective fields. Thank you and have a wonderful day.
Thank you, sir. With this, we have come to the end of formal function. I request Professor Ravishankar K, convener of the conference, to escort the dignitaries of the dais. Thank you all for joining us.
Now I kindly request all to take a tea break and join us back soon in Seminar Hall as we have a keynote session by Dr. Raghavendra Yu and by Anjan Budiga.
Hello, hello, check. Hello, hello, check. Test. Hello. Hello, check. Test. Hello, hello, check.
Hello. Hello, my chick. Hello.
Vijay.
Welcome back, one and all. Today we have the privilege of having an exceptional individuals, Dr. Raghavendra U and Dr. Anjan Gudigar, as our keynote speakers. I request Dr. Raghavendra U, Deputy Registrar, Administration, and Associate Professor Mahe to deliver lecture note on impact of AI on healthcare delivery. Over to you, sir.
So, good morning. Good morning. There should be 100% participation because we are the teachers, we need 100% participation. So, what I'll do is, my topic is impact of artificial intelligence on healthcare delivery. Because we are the group of people at MIT, we have an advanced healthcare research lab, me and Anjan. We have a big team along with our international collaborators. We are working closely on certain aspects of AI, because you know AI is a big ocean, so we can touch a small part of it, and if we are sincere, we can really touch some part. And today I'm going to present or give you highlights of what we are doing in our lab, and also what are our observations. And I'll assure you that I'll make my presentation excluding mathematics behind it. I know it's a bit difficult to digest those mathematics within this 45 minutes or 1 hour duration. So I'll restrict my presentation to the topic and application and the output what we obtain, and or the future ideas what you can plan for your maybe a project, or maybe if you're staff you can plan for your PhD, or if you are postgraduate students you can plan for your project. So before starting AI, I think you know most of teachers and students, what do you mean by AI? Because everyone will have different explanation or definition for AI, because as I said, it's a big ocean and we cannot give any definition for AI. It's very difficult for us to even, because we are working in this field from last maybe 8 to 9 years, but still we are not able to define a boundary for AI. Because every day if you read research articles, you can see it is going and going and going, because you cannot stop AI from applying it to a different fields. Because it is almost all our logical decisions have been replaced with the AI right now. If you see your research article every day, you will come to know about that change. So in general, I can say what is so. As I said, I cannot give any definition. According to us, intelligence is a part of artificial or AI, wherein I can say ability to create, understand, learn, plan and reason. So these are the basic definition I can give you for artificial intelligence. And you know, we can quote multiple examples. These are the very few examples I can say, because as I said, if you read every day articles, you'll come to know new application of AI in the real-time world or real world. So examples of intelligence behavior, recognition, interpretation, and playing logical games, proving mathematical theorems, analysis, and so on. So what actually in artificial intelligence, what actually does? So it's a branch of computer science that deals with design of intelligence system and the science of creating a system that could acquire knowledge and use that based on a reasoning. Please underline that reasoning is the one, because almost all our AI is purely based on the last term is a reasoning, because we should know the reason. Based on that, we can design some device or some decisions. So where I can see the importance of AI, this is only maybe I can say 2 to 3% of application of AI, wherein a long-lasting process, fast, efficient, and big data analysis in these field. For example, if I require some kind of fast processing thing, or I require efficient decision, or I have a multiple data or a big data, I want to process it, wherein you can think of this artificial intelligence. And AI and related fields. And again, it's only few. And we have philosophy, and we have computer science, psychology, neuroscience, biology, maths, and so on. The list goes like anything. Everywhere we can see AI right now. Next, a glimpse of what is the history of AI. Started in maybe 1943 with the basic Boolean circuit theory, and maybe in 1950s we can see some of the Samuel Checker has introduced Newell and Simmons logic theorist is a small basic concept of AI somewhere in 1950s. Now we can see, because it's almost 72, 73 years, wherein we can see our actual application of AI in most of the field. So now coming to the first point, what is AI? Let me give a block diagram of AI first, then we'll define what is AI. According to the basic theory of AI, we have a one module, it's a intelligence or a artificial intelligence module, wherein everything is the data what we provided to a AI model. That is the reason we have included only 3 modules or 3 blocks or functional blocks, wherein the middle blocks is artificial intelligence, wherein I'll give an input data, based on that it gives me an action or output. Because artificial intelligence purely works on the reasoning or the data what I give it to a system. For example, I'll introduce somebody to you in my presence today, and I'll tell everything about him. He's so and so, he's XYZ, he's working in that company, he's having a qualification of this, his height is this much, his skin color is this much, he's having a weight of this. As much as possible, I'll try to give more and more data. Tomorrow, in my absence, you can able to recognize him, he is XYZ. This is the simplest model you need to understand about AI. How AI works? AI is not a built-in brain. It is a created brain. Who is going to create that brain? We are the engineers. We are creating that brain. How? By giving more and more data. For example, I'll take the same example. I have introduced somebody to you. Tomorrow in my absence, you fail to identify that person. What is the meaning of it? The person who introduced you, that person yesterday has not given sufficient information about him, right? What is lacking now? It is sufficient or insufficient information is lacking, so that today I fail to recognize that person. This is the simplest model you always remember about artificial intelligence. Because we are the group of people, we are working mainly on a decision making, because we are working on a healthcare delivery device development. In general, computer aided diagnostic tool development devices we are working. So wherein logical decisions are getting replaced by artificial intelligence decisions. That is our area. So you can see some of the areas where in clinical side, and we have a vision side, and also we have a raw information, and also we have a action is given by a device so that AI will act to it. Next, how AI is imparting human life. You can give more example than me. right? Some of the things AI is being used to find new planet now, and also AI beats AlphaGo majority for brain games. Almost all it is assisting, and it is performing better than a human in some of the aspects. As I said again, it's purely based on what information and the boundary you have created. And also this is somewhat related to our area, what we are working in our lab. AI is helping to detect cancer cells, and also AI is being used to diagnose heart disease using retina. So these are the new trends in this field. I'll come to that point later with the detailed modalities. Now let us think what are the key component of AI. What are the key component? First thing is the speech to text to speech, some kind of a transformation. I can say it's a transformation. And machine learning and the deep learning, it's a part of AI. We'll come to that part later in my presentation, and from Dr. Anjan's presentation, we'll come to that point. And also, what are the processing things we require in AI? Image processing, object detection, image similarity, and so on. It's only a few sets, we have many. And languages, understanding, generation, and processing. These are the major 4 components which are really taking role in decision making in AI. And you know, in this case, we have seen machine learning and deep learning part. I will not touch much about this machine and deep learning part. Dr. Anjan will take that part. Let me go into a machine learning basic thing, wherein we have a majorly we have 3 categories. One is supervised and unsupervised, and we have a reinforcement model. Wherein supervised learning with the labeled training set. Because I had given you one example wherein yesterday I have introduced somebody to you because there was a guiding force who is going to give information to you about data is having a supervised learning, because we are giving the labeled data. Labeled data is nothing but the true information. He is XYZ, that is a labeled data. If I am not telling this is a person, then it is a unlabeled data. It's a labeled data. It comes under supervised learning. Somebody is there to assist you in the beginning. Later it is your responsibility to make a decision. So, wherein we have one more unsupervised learning. Unsupervised learning is not having any labeled data, wherein I have to decide which category he belongs to. For example, if I am planning a human detection model using AI, then I should understand without any labeled data or without any person assisting me in understanding who is man and woman. Based on my knowledge, looking at this, looking at surroundings, I have to decide who is that person. It's a purely unlabeled data, comes under unsupervised learning. And the 4th one is a reinforcement learning, wherein learning based on feedback or reward. Because continuously you are making decisions and taking a feedback, and those part will be taken, and every iteration you are going to be more perfect and perfect. So that at some point you will come to know about my decisions are correct. So it's called as a reinforcement models. Now I'll come to our topic. We are working closely on computer aided diagnostic tool development for some of life-threatening diseases, because the next we have a Kasturba Medical Hospital in Manipal. So we are closely collaborating with them, and also in multiple hospitals in the world. We are getting data from Italy, we are getting data from Australia, we are getting data from Singapore and Malaysia. We have a collaboration over there, and we are working with them closely on different diseases. I'll come to that point in my coming slides. And majorly we are working with X-ray, MRI, CT and ultrasound. These are the medical imaging modalities. Also we are working with signals also, like EEG and ECG also we are working. And majority area with respect to X-ray, MRI, CT. And it processes digital images for typical appearance and to highlight conspicuous sections in order to support a decision taken by a professional. For example, we are using some of the modalities, and if I ask you to see the difference between those images with the naked eye, you are not able to distinguish them. We are using such images so that we are trying to identify some of the signatures which are a initial indication of some of the diseases. We'll come to that point later. And this is a typical block diagram if you see of any of a computer-aided diagnostic tool, not necessarily our work. It's a general block diagram of a CAD tool. And you can see input image or a signal is the first part to our model. And we'll come to that point now. What are the type of a data description we are using in decision making, especially with respect to AI decisions? First thing is, this is a fundus images. I think you are aware of this. It's an eye image. So through this eye, we can predict so many life-threatening diseases. Now, initially it was there with the diabetic retinopathy. It is because of diabetes. And also it is moved to a glaucoma. It's a vision loss issues. We can identify through this fundus images. And now we are working with cardiovascular diseases can also be detected using fundus images, because getting fundus images are purely non-invasive. There is no pain, right? So most of the work in the current trend in the world is moving towards a non-invasive part, because I'll come to that part, because almost all the testing methodologies what we follow, which are with respect to a life-threatening diseases, are invasive technique. Invasive techniques, just example is taking blood. It is having a pain, right? Is there any way I can remove that? Without the pain, can I take something out and I can analyze it? These are called non-invasive techniques. This is one type of images we are using to identify a glaucoma. Some of the key component of this images are highlighted, right? It's a pressure inside your retina is going to be captured. That decides whether you are having glaucoma or not. So next modality is about diabetic retinopathy. It is about diabetic or excess high level of glucose results in vision loss, or maybe you are having issues with your vision. So this is using DR images or diabetic retinopathy. Again, the modality is our fundus images. We have a fundus camera. I think most of you have seen when you visit eye hospitals, right? So next is, this is another modality we are working with respect to ultrasound, wherein we are calling it as a fatty liver disease, FLD. This is a one upcoming disease now. It is purely because of alcoholism and fatty, your junk food. So this results in fatty liver, and the next stage of this fatty liver is a liver cirrhosis. So we have to identify it's in early stage so that we can prevent them from liver cirrhosis. I think liver cirrhosis, liver cirrhosis is liver cancer, right? So this is the initial stage of it, and if we are able to identify any of this using AI in their initial stage, we can prevent them from cancer. So next is digital mammogram images. It's about breast cancer. We are working with those breast cancer images. It's a mammograph images. And you can see it's the quality wise, we don't have much importance here, but still our effort is more required in these cases where quality is less. So this is one more thermogram images for breast cancer, and this is age-related macular degeneration, one more category of disease which can be detected using fundus images. And next is a thyroid tumor ultrasound, again a thyroid cancer detection, and we are trying to identify some of the early signatures of this ultrasound using this ultrasound images. And this is about heart failure ultrasound images, because based on the current functioning of the heart, we can predict whether the person is going to get heart attack in future. It's an ongoing project now, because we have not arrived any pure conclusion, because we cannot generalize this system. We have developed a model for this now, but we cannot generalize that system, but we require a multi-centric data for this, because if I take Indian population and I cannot generalize that system. So I need a multiple centric data. So because we have used 3 to 4 countries data, Australia, Malaysia, Singapore and India. We are trying to collaborate with more people now so that we can generalize this system. It is going to tell you some kind of early signatures to assist. And please note one thing, we are not going to replace any doctors. We are trying to assist doctors in their daily routine screening. So next thing is the data pre-processing about a breast cancer. We can segment this part which is a really interesting part for us. And you can see the last image of the bottom is having only the breast region. And also this thresholding method is one of the simplest method which you might have studied in image processing if you have studied in theory subject. So we have a different thresholding methods wherein you can see only the region of interest is thresholded, only area which I require can be obtained from this thresholding method. And also this is about congestive heart failure disease. You can see the original image is represented in different formats. Usually we'll call it as a feature transformation. Because as I said, if I give you original image of a patient who are not having any heart disease or the patient who is having heart disease, using human naked eye, you cannot differentiate anything. So the first step is we are trying to transform them into a different domain wherein I can see really some kind of changes. You can see when I apply a variational mode decomposition methods, I'll get these three different patterns. These patterns are different for normal and the abnormal patients. That is the one thing we are trying to extract, which is called the early signature of image modalities. This is another one wherein we have used a gist transform. You can see original image is represented with multiple kind of patterns. And these patterns are completely different for normal and abnormal patients because their patterns in the original itself is different. That is the reason we are getting different patterns for different patients. But with human visual system, we are not able to discriminate them. That is the reason we require AI role in this field. And this is again a continuation of our mammogram images. See how we have clearly segmented the images so that directly without any further, we'll call it as a redundant information. For example, most of our big data analysis is having an issue with the redundant information. The first thing is we need to remove those redundant information or irrelevant information. For example, if I am developing a model using AI to detect human face, right, in Indian population, do you think if I take a skin color, whether my model will work? Definitely no, because Indian population are having a similar kind of skin pattern, right? So those are the redundant information or irrelevant information which is there in my system that I need to remove. That is the reason you can see only the part which is important for me I have extracted. And this is another one which we have used using Hawk transform, histogram of gradients, that we have used to segment breast region. And next is a representation. Once I take original image into a transformed image, it's still an image, please remember. It is still an image. You can see that this is still an image. But now I'll use something new, which is again a second level of refinement wherein most of my redundant information will be removed, which are listed here. You can still try this if you are interested in these methods of transforming images. Discrete cosine transform, I think those who have studied the DSP, right, you have studied this, you might have studied this discrete cosine transform. Discrete wavelet transform, it's called a DWT. This is also one feature transformation. Shearlet transform for nonlinear features and a curlet transform for again nonlinearity we can use, and many more. These are only the few basic techniques which you can use for feature representation. And next we have from the image or transformed image, now it is a number game. Now you need to understand, you need to extract few numbers which are unique among your different group of people. For example, if I am using or trying to develop a model which can detect a normal patient and a patient having a cancer using any modality, CT or MRI, just I need to arrive at some numbers which are unique for both the categories. Those can be done with the feature extraction part, right? What are the features? Features are a useful information, right? Or significant information which are unique. So those, with that definition, we are trying to attempt to extract the features now. These are the major area or major work or the technique which we can use those who want to have project in this area, please note down what wavelet transform or wavelet energy features, entropy features, texture features, and for nonlinear features, higher order spectral feature, HOS features are a very efficient feature extraction methods which we extensively use in different projects. And this is one synthetic data generation wherein you can see in real world problem, if I want to have or if I want to develop some model, I cannot expect I'm getting equal number of samples in each category, right? Then I require some technique to balance them. Otherwise, what happens? AI really gives, or maybe your machine learning or deep learning methods really give very bad result than human decision systems. Because somehow I need to have almost all balanced data. Balanced data in the sense 10% or 100% with cancer and 10% or 1000% without cancer. 100 and 1000, it's a purely imbalanced data. So before giving it to any machine learning algorithm or deep learning algorithm, I have to have a balancing those things, and it comes in synthetic data generation part, wherein synthetic samples you can see here, and this is sample in R1 wherein almost okay with this. Now if you come to this part, you just see green are having in the leftmost, green are having maximum than the red. So in this case I cannot proceed further without balancing them. So in this case I can balance it. Based on the minority data, I can generate some synthetic number of data so that you can see the balanced data in the right side. So almost all, I cannot say it's equal to the majority class, but very close to the majority class I can generate synthetically. It is not created, it is not taken from a real world, it is a created data. This is a synthetic sample generation method. Once I complete that synthetic sample generation method, next part is whether I have to go for a machine learning classification model or a deep learning classification model. These are the very basic, and or maybe before that we have a dimensionality reduction method, because as I said, if I go for any of our features, for example HOS feature, you will end up with multiple data. So you need to reduce those, again remove the redundancy and make those features ready. And these are the some of the feature dimensionality reduction methods, principal component analysis, kernel PCA, graph based kernel PCA, and so many things. These are the few which we have tried in our lab and working efficiently for any number of data. And the next is again, next level of removing unwanted data is a selection method. These are the selection methods, student t-test. This is not with respect to AI or ML, this is purely statistical based methods. If you see analysis of variance and some of the softwares, if you see, which are analyzing data or feature analysis software, you can see the student t-test and ROC curve and purely statistical based methods which can be used to analyze your data and remove some of the unwanted component. And feature learning and classification, here it's most of my machine learning part I have listed. These are some of the classifier we regularly use when we take our platform as a machine learning. Decision tree, fuzzy classifier, naive Bayes and probability neural network PNN classifier works better compared to some of the other classifiers. And a simple example in this is a support vector machine. For example, I have two set of data. How can I discriminate? Because you can see two set of data, one as circle, one with the dot. How can I separate them? I can draw a line like this, right? So I can also draw a line like this also. I can also draw a line like this. Though I have a number of possibility to separate them. Now, finally, this many possibility for me to separate them. Now, if I see the exact region between them, see there is one data, and this is a complete area with which I can separate them, which is called a hyperplane, which I think those who have worked in support vector machine, you know, hyperplane, which are very close to the points, belongs to two different category. One is dot and one is a circle. You can see those are my support vectors. Suppose if I'll get a one class which is having a new sample, if I want to segregate them, I just compare it with those points so that I'll take a decision whether it is a class A or class B. Similarly, these are called as support vectors. And next is when the data is not separable linearly, right? For example, this is a real world problem. If I have multiple samples which are clubbed together, what are the possibility for me to segregate them? And this is the way we'll call it as we are using a kernel functions in the classifier, which you study in your subject, wherein it is going to take a features or a sample into a little higher dimensional space. This is a pure mathematics. It is taking samples into a higher dimensional space wherein you can see different information. For example, if I hold my mic and this presenter like this or like this, you can see only mic. You cannot see the presenter. Now what I'll do is I'll take these samples into a little higher dimensional space so that I'll rotate them like this. Now you can able to recognize two. So this is a simple mathematics of a kernel functions. It takes samples into a higher dimensional space so that you can see different things which are not available in a previous dimension. So, and next is a cross validation technique. At the end, suppose I cannot say, as I said, I cannot say I have developed a model and it is working fine, it is the final model for everyone. So I have to test it with multiple sample, I have to test with multiple geographical area, and I have to come out with the decision whether my algorithm is working fine or not. This is a complete workflow for a CAD system. You can see the pre-processing and then one method of transformation, then a feature extraction and optimization technique and a decision making. And now we end up with the 2D information what we have decided. Now, is that 2D sufficient for us to analyze any of the data? Definitely no. What is the usage of 3D? We'll get some additional information so that additional and beneficial information or decision can be done. So now this is the some simple example, 2D and 3D. What is the difference? Just to say, in first instance, I can say I'm getting more information than the previous one, right? If you see this, you have more information in the right. So let us start with that 3D, how I can generate 3D. The simplest way to generate a 3D is a binocular vision system. What is a binocular vision system? How a human vision system is working, right? We have two eyes. Why two eyes? So that we'll get some kind of 3D information of a particular face. For example, if I throw a ball towards you, you close your one eye and try to catch it. Next time I'll throw a ball towards you and you just open your eyes and try to catch it. Which one is easier for you? When you open both the eyes, right? What is the issue? What you are really lacking? What is really lacking, students? If I close my one eye and if somebody is throwing a ball, I'll try to catch it. Second, I'll close both the eye and I'll try to catch it. Second time, I can easily do that. What may be the reason? Because a portion of a 3D is created in my brain so that it is clearly tracking the position of the ball so that he can easily catch the ball. This is the one which we are using. It is called a stereo vision. Stereo is a 2, right? Stereo vision. We will mimic the human binocular system. So we'll see this is a way, 2 camera placed side by side. Now what is the advantage of this? So this is the one way we can capture scene, and this is the application of it, right? And now we are working with the medical domain so that these are the real requirement for us. And you might be knowing about robotic surgery purely based on this visual system. And now these are the different sensors or the cameras we are using in labs, not us, in medical labs they are using to capture the different diseases. You can see the stereo vision, stereo mag endoscopes, and many of other modalities they are using to capture. Now see how it works. It works similar to human binocular vision. A person is standing over there. I'm trying to observe the person from 2 different angles, like my eyes. And please remember, there is in between 2 eyes, there is a gap, right? There is a gap. It is called a distance between 2 focal length, right? And for example, all of you try one thing. All of you hold your finger in front of your eye. All of you. Close your one eye and open that and close the another one and do it simultaneously, what do you feel? What do you feel? You feel like finger is moving, right? Why? What is the reason? There is a dedicated point for that particular object, for example my finger, in both the eye, right? That is a dedicated point. Now, you cannot say always your point is same for both the eye. Now, what I'll try to do is, I'll try to do those positions, identify those positions and generate another map. It is called a disparity. I'll come to that point later. And this is a pure mathematics, right? We have a distance, like this is a distance, right? This is a 2i and this is a focal distance and this is a person object. Now, if I know this distance between two eyes and the focal length of these two camera, I can identify the distance set. This is the one easiest way through which I can generate a 3D of any scene. This is another projection matrix of that. I will not come to that point later. Finally, I will end up with this kind of structure. You can see here, this is an image taken from my left camera. This is the image taken from my right camera and I obtained a disparity map of it. Now, you just closely observe this output wherein this lamp is placed here in both the camera. If I ask you one question, which is the object very close to the camera in this scene? Huh? Yeah, your answer is correct. What is that? In this, my question is, in this scene, which is the object which is very close to your camera? Because you have captured this scene using your mobile. Lamp is the one which is very close to the camera. And now you observe this image. What is the color given to your lamp? White. Okay. In this case, again, I'll come back to the previous case. Which is the object far away from your camera? Maybe Almera, right? This Almera is having a large distance from my camera. And what is the color given to it? Black. The one which is having very close distance is having white, and the one which is having very farther distance is converted into a different color. Now, are you able to design one robotic system with which your task is to identify distance to that point? So that whatever the object which are very close to my camera will be highlighted with white color, or the object which are far away from my camera is highlighted with different color. What is the meaning of it? What I obtained from this? Distance, right? So distance is the one, using just two images, I can able to identify the distance, which is extensively utilized in most of the robotic, right? And the similar concept we are, because we have worked in this domain, not with respect to clinical domain, but in a computer vision domain in our lab. I'll show you those results later so that I can identify a distance now. And how can I use this in medical domain, especially for robotic surgery? I can see exactly tell what is the depth with which I have inserted a catheter into an organ. So that's the closest distance I can obtain. And these are some of the methods we obtain. Now you can see one more example. This is one scene of a left camera. Similarly, I have a right camera output. And see now, I have obtained only the objects because I know how far they are placed from my camera. And I can, one more importance and the benefit of this is, if I know this scene, it is a perspective geometry, right? Perspective geometry in the sense, this is a scene, I kept my camera here and it's capturing a scene. Now, if I place my camera on the top, it's called an overhead camera, right? So now just see, I have captured a scene using this perspective geometry, but simple mathematics will give me how can I project. It looks like I have captured the scene from a overhead camera. I'll show you that. This is a technique and this is a floor region. Do you think it is taken from a overhead camera? It is a floor region. I have kept my camera like this. I have captured a scene. This is a floor area. Now using a simple mathematics, you can see here, how it looks like, these 4 positions are the positions of these objects. Now see how they have placed, how it looks like. It looks like the scene is taken from a overhead camera. How I have done it? It's a simple mathematics. I'll show you the video of that later, in which we have done, developed in our lab. These are some of the output of those scenes, and these are again, see, using those mathematical models, we are able to detect them, and now we are in a stage of applying it to a clinical domain, wherein we can include artificial intelligence decisions, so that even this decision is going to be more perfect. And applications are multiple, and we are trying to use this 3D model to multiple methods, wherein combined with CT and MRI, stereoscopic endoscope we are planning to use, and this stereoscopic microscope also we are planning to use this technology, and biological specimen observation using the 3D stereo microscope. We are collaborating with KMC for this, and these are some of the applications what we have developed. Now, before showing an actual demo of the model what we have developed, let me take a takeaway from this presentation is machines that learns to represent the word from experience, and deep learning is no magic again. Please note, just statistics in a black box, because I don't know what is going on inside. That's the reason we are calling it as a black box. But exceptional effective at learning patterns, because the output is tremendous. We cannot compare it with any of the other models. Transition from research to consumer product will make the tools you use every day work better, faster and smarter. These are the takeaway. Now let me take up, this is my lab details. Me and Anjan, we are coordinating with the lab, Advanced Healthcare Research Lab. Those who are interested, you can visit in MIT when you are free. And these are my collaborators. We are collaborating with more than 8 countries. And all are reputed researchers in different domains, and we'll have your question later. Before that, my time is almost done. Let me show you some of the output what we have obtained. Now I think you can see some of the model. You can see this is scene. It's not our scene. It's a publicly available scene. Even if you are interested, you can work with this. Now see how we have projected. It looks like you are observing this scene from the top. Is it so? It looks like you are observing the scene from the top, but it is actually captured from a perspective geometry, not from the overhead camera. This is the beauty of our mathematics, because we are not understanding the actual application of the mathematics. It's a simple mathematics. It's called a projection, top view projection. If you're interested, you can work top view projection, which gives you a overhead kind of projections using a scene. And also I have one more, which with AI technique we are planning to incorporate. Now you can see, using those disparity, as I said, the distance. This is the distance. I have refined it. Now you just see whatever the portion of the object which is interesting to you, because I am interested in the upper portion of a human body, right? See here, only upper portion is visible, because I have removed it, because I know the 3D point of it, so that I can remove them. And now you just see how it looks. It looks like I am observing those objects from the top view, right, or overhead camera projections. Again, there is a tool. This overhead camera projected images can be back projected to a perspective geometry, which is this. So that is the beauty of our mathematics. Hope have given basic understanding. I know it's a bit difficult to take entire AI or anything with a short period of 45 or 50 minutes. If you have any questions, I'm happy to answer with respect to this domain. Any questions? Or if you have any interesting fields to explore, we are always ready to collaborate. And if you don't have any questions, request Dr. Anjan to continue. And if you have any questions, we can have post-presentation session we can discuss. Thank you.
Thank you, sir, for your most relevant and informative speech on impact of AI on healthcare delivery. I kindly request Dr. Anjan Gudigar, Assistant Director, Administration, MIT Manipal, to deliver keynote address on topic Current Trends in AI.
Good afternoon, everyone. Dr. Raghavendra had given a nice introduction regarding the application of AI in various domains and how to develop the model in the computer vision as well as in the medical image analysis. So this is an entire thing what we are developing in our lab. Okay. So now I wanted to discuss some current trends in AI techniques. Hope some of you are from EC background and computer science background, right? So whenever you want to develop some kind of models, right? Any application, any AI based applications. So basic thing is you should know the signals and systems. You should know the digital signal processing, image processing, and later computer vision. So that's why some of the subjects you will be finding in as your core subjects in third semesters, right? So hope all of you have studied the signal processing, right? So now what I will do is I will just move a little bit inside to an algorithm and try to understand how can we develop different models. See, when we are talking about AI techniques, right, I can apply these things to any kind of applications. For example, it may be a CAD tool or it may be a advanced driver assistance system. You might have heard in some of the advanced cars, right, unmanned vehicles. And it may be a computer vision applications, right? So whenever I want to build some models or some applications, for example, I need to take an image, correct? It may be an indoor image or it may be an outdoor image. Or it may be a medical image like CT, MRI, PET, right? The different modalities of the images. Now, you need to decide which area you want to work. Either you want to work in the computer vision or you want to work in the medical image analysis. See, all these things, why me and Raghavendra sir are stressing all these things is, see, you are in a third semester or you are in a second year. This is the right time to select your domain to work. See, the world is very fast. Okay, so you need to cope up with the things, what is happening in the state of the art techniques. So that's why. So this type of conferences and keynote addresses will bring you a lot of things, right? So that you can choose your domains of interest and you can start working on that. I think some of your faculty members, your teachers are also working in this area, okay? So now, I want to develop a model. What are all or using artificial intelligence. So what kind of methods which are available for me, or how can I categorize the different things that is required for me to develop some model that can automatically or that can mimic the human brain, okay? So for that, you will be having machine learning, okay? So I think you might have heard machine learning, right? So you want to make a machine to learn with some examples, correct? So what exactly the meaning of this? When you are feeding a machine with some information, what do you mean by the information, or what is the input to the machine? For example, it may be a image or it may be a signal. What exactly the meaning of image? Say for example, I am taking a photo of this classroom or this auditorium, right? I want to make a system so that it can understand that what exactly happening in the auditorium, or I need to identify each and every phases of the student here, right? That is one application, am I right? Okay, so for that I need to go for, or I need to learn my missions, or I need to give some training to a mission that yes, these are the data which are available for you and make use of that for the future use. Correct? So now, after this, we will be having that there is one block I have written there, that is the deep learning. What does it mean? It is the subfield of this machine learning. How can I decide my application requires the machine learning or my application requires the deep learning? That is also very, very important, right? For example, I want to analyze the data that belongs to the student who are there in this auditorium. That is one application. Or I want to analyze the student comes under the entire university. That is the another application, right? So if you have a small amount of data, right, you can easily train. Okay, you don't have much complex system to understand, right? That is what your machine learning is. If I want to have the bigger data, right, so I need to train my system with the more number of complex algorithms. I need to go deeper and deeper. So that is what the deep learning. So what are the things that are required for the machine learning and the deep learning is, you need to have a sophisticated hardware and also you need to have a bigger data. So that is required for the deep learning. For the machine learning, a smaller data set is sufficient. See, whenever you want to work with the artificial intelligence, one should be able to understand the machine learning. When should I apply the machine learning and when should I apply the deep learning? Correct? So we'll try to understand what exactly this machine learning and deep learning is. For example, I will start with machine learning. So you will be having, see, we are talking about the images. It is a 2D signal, right? So when you are reading the image, what you are expecting? You are expecting all the pixel values. Am I right? So the small information in the image, right? So what you are expecting, these are I think you might have heard pixels, right? Pixels. What does it mean? It is the small chunk which can give you the information regarding the image. So the image what I am taking here is the input image. It may be anything, right? So now I will be applying different algorithms to build some automated model. There are two things. One is the machine learning and another is the deep learning, right? In the normal conventional method, when the data is very less or we have a sample size is very, very small. So how to go about that? What are the different steps which are available for us? Just now Dr. Raghavendra had mentioned, right? What are the different methods which are available for machine learning? For example, I want to understand the entire classroom, means I need to extract the features of particular person, right? So once you understand the features or once you extract the features from the student, right? Later I need to go for the classification. This is a normal pipeline structure of the machine learning, okay? But in deep learning, it is not so. In the deep learning, you will be having one block, for example, right? As a black box, you are giving the input and you are getting the output. What is there in the black box? In a black box, you will be having a multiple layers and the classifiers, means everything is unified inside the black box. That is what the meaning of deeper and deeper. So you are trying to learn the images, or your system is trying to learn the image by taking more significant features from the images or from the photograph of a person. How it can be done? By including more number of layers. When you are adding more number of layers, it is more deeper and deeper, right? So initially you are trying to extract the features like edges. Later you are trying to extract the sophisticated features from the entire image. So now on a whole, see, this is one example I have taken just to show how exactly the COVID-19 has been identified using both machine learning as well as the deep learning. So we have one advantage in the machine learning, that the program writer or the one who is developing the program, right, he should understand what exactly he is going to do. What are the features he is going to extract? The features means what? That is, what I can say is, which can give you the signature of 1 or 2 images, right, of a person. So now, when I am considering I just mentioned there, handcrafted feature extraction means as a programmer, I should know what are the features I am going to extract. Write a program for that and get it done. Later, apply some dimensionality reduction, then the ranking and classification, do the classification. Okay? So that is the one thing. Another thing is, we need to go for CNN based feature extraction. Right? That is what I meant. That is, you need to add more number of layers. See, now little bit I am moving towards the insight into various algorithms. Okay, try to understand it. I just made it very simple slides so that one can easily understand. Okay, so this is how exactly we can, any problem is given, we can easily identify these solutions like this. Okay, next. So this is one more field wherein we can go for, instead of classification, I need to identify, means I need to segment, right? So where I need to find out, or I need to locate where exactly the person is, or where exactly some abnormalities in the image. That is what the application of the algorithms we need to develop, okay, based on the ultrasound images, or it may be a fundus images. Okay, so now, what exactly the basic idea for this machine learning architecture? You have a feature, say for example, 1,000 students are there. I need to extract some significant features from the students, right? So it is very difficult. See, extracting the features means what? It is the numbers, right? I am feeding that numbers to a computer so that the computer can understand, or my algorithm can understand, yes, this is this person X and this is person Y. Right? So for that purpose, we need to follow a different algorithms or different steps in a pipeline manner. That is what I have shown there. Okay? So once I am extracting the features may look like this. See, this is the first one, is the data, the raw data I am taking, and I am exposing those things into some space. So there you will be finding that the class 1 and class 2, say for example, 2 classes are there. One is the red and another is the blue. So it is very difficult for a computer to understand which data it is, because all these 2 data are overlapping. So next step, what is, as a developer, our step is to, we need to separate these 2 data sets so that my system can easily understand. That is what we need to do whenever you are trying to develop any kind of algorithms. Your step is to understand, or your work is to make the data, or you need to separate the data so that your system can easily identify the task. Okay, so that is what you have to do in the machine learning algorithm. So next, see, as I mentioned, nowadays you will be seeing all the AI techniques, whatever it may be, right? So everything is applying the deep neural networks, right? So one of the very interesting neural network is convolutional neural network. How exactly it works? So there are 3 major parts for the convolutional neural networks. So one is the local receptive field, shared weight and the bias, activation and the pooling. Those who are working in the CNN, I think you might have understand what are these steps which are required for the convolutional neural network. I think in your theory classes you might have studied the convolution, right? What exactly the meaning of convolution? Right? See, this is required here. See, you should understand whenever you are trying to understand the theory, right? So you should be able to also understand how can I take the theory into application part, into a real world, how can I apply? See, whenever I want to extract the features, right, I need to use the convolution as one of the important operations. How do I do that in the convolution neural network? Say these are the structures. Okay, so the neural network is having the input and the output. In between you will be having the hidden layer. Okay, so this hidden layer generally, how do I generate or how do I map with the each and every neurons in the convolution neural network is by means of convolution. Okay, so that is what the equation is given there with the weight and the bias. The major advantage of convolution neural network whenever you are using it in your application is you can easily identify the edges or the blobs. Why? Because the patches or the window based technique you are using over there, so that the initial layers in the convolution you can easily extract the edges or the blobs. Okay, so this is the heart of the convolution neural network. So the next we have while understanding the convolution neural network, there are some activation layers, right? What are those activation layers? One is the RERU layers, and later we need to go for pooling. Whenever I say you need to reduce the dimensionality, why I need to go for reducing the dimensionality? Because you might be having very constrained computers wherein a limited memory, or you are not having a much or computing facility in your computer. In such situations, say try to understand if you have an image 255 cross or 256 cross 256, how many elements you are having? 256 into 256, right? So you want to process such thousands of images. Try to understand, so what is the amount of memory you require? Correct? So for that purpose, there is one essential step is dimensionality reduction. We can do the dimensionality of an image or dimensionality of a matrix by using pooling. This is a simple example what I have taken. Okay, so generally how it looks like whenever you are talking about deep learning, right? So I said you are introducing more and more number of layers in between input and output. So these are the layers, right? So input is your image, and the output finally what you are expecting is your result. Either it may be a object identification or it may be a identifying the abnormality, anything, right? So but in between, right? So you need to decide the number of layers. So how do I get the layers? By using the convolution operations, by using the activation function, by using the dimensionality reduction techniques, right? So you don't know, this is the entire one box wherein, so what you are finding is, consider it as a black box, you are giving an input as a image as the input and you are extracting the output, that's it. Internally everything, the feature extraction, classification, everything is unified there. Okay, so next, how can I use this CNN, right? See, I can use this CNN in two ways. One is I can use this to extract the features, or I can use the pre-trained model to identify something else, right? So we have some here, we have some data which is given to some neural network, right? Some which is having 50 layers, right? Finally, I am getting some features. Features means it is a number, right? So these features I can make use, and I can make my own decision instead of taking a sophisticated classifier like SVM or some KNN or some naive-based classifier. I am not using any classifiers. I will be using my own methods to understand how exactly I can categorize by using the features. That is what we can make use of CNNs. Okay, so this is one advantage of CNN. Later I can make use of, or you have designed one model, right? Or you are identifying a person. But the same model can be utilized for, or I can make use of, or I can transfer the knowledge that is taken by my model for one application to identify some other application. That is what the transfer learning is. Okay, so these are the things you can make use of CNN. So you can think of this area, very interesting area and emerging area, wherein you have a lot of scope to identify some abnormalities for this. See, basically when I say the computer vision or the medical image analysis means three things you need to remember. One is the segmentation, another is classification, and another is the feature extraction. These things are very, very, very important to build an application. Okay, either of the stages or these key phases you can select and you can work on that. Okay, so next we have, say I want to enhance the performance of the CNL. Okay, how do I do that? As I mentioned, there are so many layers. Okay, so the layers in the sense what? It will give you some information regarding the image, right? So when the layers are giving some information about the images, okay, so next what I want to do is, I want to enhance the capacity of my model so that by adding some extra attention to some of the layers, right? So how do I do that? I want to add some attention to some layers. See, the layers, the significantly I can say that you will be having the information in terms of channel, or you will be having the information in terms of spatial. These two things are there. Okay, what do you mean by channels? When I take the RGB image, you will be having a three channels. One is R, G and B. I can extract the sufficient information from RGB, right? Okay, so that is the one thing, that is the channel attention, and another is by looking at the image, the significant features I can extract, say edges or say some holistic features, that is the spatial. I want to bring some attention to these layers. Okay, so that's why I will be introducing two modules. One is the channel and another is the spatial. So we have internally the modules looks like this. It is completely mathematically you need to do like this, in the sense the convolution you are doing, some pooling you are doing, and some activation functions you are doing, right? So serially or the sequentially you can make use of this so that you can bring some attention modules, or you can bring some attention to some part of this specific part of some abnormalities in the MR images, CT images or PET images, anything. Okay, so when I use this, so we have developed this, any abnormality in the brain images you can identify like this. Okay, so this is what the automated tool we have developed in the lab, right, wherein any MRI images you give, any abnormality you can easily find out by making use of these attention models. Finally, what is our, say, when I say the computer aided tools, or when I say ATSR, in the sense advanced driver assistance system, or when I say some segmentation techniques, right? So what is the end use, what is the end purpose? Say for example, when I consider the CAD tools, right? Our intention is, see, in India we have many rural areas wherein you will not finding any doctors in the or the expertise in the rural area. In such situations, see, whatever the CAD tools we are building, right, we have next in the futures, we want to install it in a rural area so that everybody can get benefited out of this, right? How can it be implemented? Say for example, so this is what we planned in the future, right? So wherever you will be having a main hospital in the main city, and it is, or in the rural area, if somebody is there to take the, say this is one example for how to generate a IoT based system so that the rural people or the people, those who are not finding the experts or those who are not finding the very good hospitals, right? So they can, if one X-ray machines are available, okay, they can take the X-rays and put it in the cloud. Okay, the person who is sitting or the developed algorithm will do everything, and it will give the result to the patient, right? So whether he is going to take care of next, whether he need to meet the doctor or he is okay with the things, right? Everything we want to analyze in the cloud-based analysis, okay? So this is what the next research is going on, okay? The currently everybody is moving towards this so that everybody can get the benefit of this AI-based algorithms, okay, anywhere in the world. So either you can have the X-ray machine, CT or MRI, right, or any kind of signals that should be analyzed in a cloud, and it should be, or the result should be given back to the patient, so that one can easily understand what is the status, whether he has to okay with the condition or he needs to meet the doctors, right? You can think of this. Anybody want to do the research in this, you can think of this, okay? This is what the currently trending area. Okay, so with this, so I have given the gist of the machine learning and the deep learning. Okay, so if you want more to understand, you can approach us anytime. So because some of the mathematics I haven't taken, right? So if you are really interested, you can approach us anytime. If you have any queries, please ask. Thank you. Thank you so much for patiently listening. Okay.
Thank you, sir. Thank you for your enlightening speech. Truly, it was a great insight to the current trends in the field of AI. Now the session is open for questions. So audience, any questions?
Any questions?
Thank you once again, sir. With this, we have come to the end of the keynote session.
I request the students to go to your classes and follow your timetable. See, I request participants and faculties, please stay back. Now there is a small session on topic research ideas by Dr. Raghavendra U and Dr. Anjan Gudigar, exclusively for faculties and participants. I request all to take the benefit and you can clear your doubts. Students, you can leave, go to your class.